So Newton's universal law of gravitation obviously has something to do with the attraction between bodies due to gravitational forces. Again, the main idea here is that the force due to gravity that mutually attracts two bodies across a distance pulls them toward their mutual centers of mass. It pulls them together. Really, if you want to picture it, you can picture sort of a center of mass right here, and if there's mass 1 and mass 2, there's a force that acts on mass 1, we might call it force of 2 acting on 1, and there's a force that we might call force of 1 acting on 2, mass 1 acting on mass 2, and the two forces would tend to pull the two bodies towards a mutual center of mass, this X here. That mutual center of mass is the spot where they would really coalesce into perhaps even one object if there's enough gravitational force. Now, if there's two bodies where one object is much, much bigger than the other one, the center of mass could be inside of the larger object. At the end of the day, though, force of 2 on 1 and force of 1 on 2 are going to be equal in magnitude, but, this reminds us of Newton's third law. They're going to be opposite in direction. It's a mutual attraction. That's the main idea, though. The force of attraction also has a proportionality. As it turns out, mass 1 times mass 2, or the product of mass 1 and mass 2, is proportional to the amount of force that the objects feel in terms of the attraction, the gravitational force. Not only that, but another proportionality could be stated. The force due to gravity is inversely proportional to 1 over r squared, where r squared is the square of the radius of separation. Now, when I say radius of separation, I don't mean like between their surfaces. I should be very clear about this. Radius of separation means the separation of their centers of mass. So if I've got these two objects, each one of them with its own individual center of mass, yes, they get attracted towards their mutual center of mass, but the distance between them, r, indicates the distance between their individual centers of mass. And so that's pretty much it. There's this idea of attraction between, really we should say, two or more bodies towards the system's center of mass.